Welcome back, YouTube. Today I'm going to show you how I made a working virtual reality desktop computer using the Unity game engine. What this is a standalone computer in VR where you build the user interface and the functionality yourself. So if you're building a VR game and want to allow your player to use a computer for changing settings or opening locked doors, this tutorial will show you all the back end of interacting with the computer and put you well on your way for your own implementation. Also for this tutorial, I'll be using the Steam VR plugin from the Asset Store to handle my VR interactions. While you don't need a full understanding of the plugin, some basic familiarity with it will be useful for you. As always, I'll put links in the description for all the scripts that I use in this video. I'm Reedster with Far Gaming. Let's get started. First off, I'm going to start with my keyboard and mouse since those are the two things I will be physically interacting with. I'm going to go through and do the same thing to each of the three buttons on my keyboard. First, I'm going to add a Text Mesh Pro component, change the positioning and the size of it respectively to get it to match the size of the individual buttons. And then I'm going to write whatever text is going to be on top of them, such as back, delete, or enter. Next, I'm going to add two different box colliders to each individual button. One box collider is going to be a regular box collider that will allow things to collide with it, and the other one will be a trigger box collider that will be a little bit bigger than the other one and span around the key just a tad bit more, and that will detect whenever a hand or something is coming in to collide with it to push the button itself. Next, I'm going to tag each of my buttons depending on which button they are. So the left one is going to be my back key, so I'm going to give it a back key tag. The center button is going to be the delete key and receive a delete key tag, and then same thing with the right button is going to be the enter key tag. Now I'm going to create that script called button controller. I'm going to get rid of these two lines at the top. We're only going to need to use the one that says using Unity Engine for now. So I'm going to start with three private variables. The first one is just going to be an int called collision count that determines how many things are colliding with that button. Then I'm going to have two vector threes. One is going to be for the up position of that button and the other one is going to be for the down position. And then I'm going to have a float that I can set for the offset to determine how far the button should push down and how far it should come back up. And lastly, I'm going to have a public game object of the cursor because that's where I'm going to have my main computer controller script. So I'm going to need to reference that later in the script. In the start function, I'm going to set what the up position is, which is where the buttons currently are. So I'm just setting that variable equal to whatever the current transform local position of that button is. Then I'm going to set up my down position variable. It's going to be a new vector 3. It's basically going to be the current position of the button minus whatever the button pressed offset is, and that's going to just be on the y-axis. I'm going to add a onTriggerEnter function, which every single time something enters that box collider, that's the trigger, the collision count variable is going to go up by 1, meaning you have another object colliding with it. And then as long as collision count is greater than or equal to 1, then we are going to set the local position of the button in the down position so that it looks like it's being pressed. Lastly, I'm going to make an onTriggerExit function. This one, whenever something stops colliding with the button, I'm going to lower the collision count by 1. And then if the collision count is equal to 0, then I'm going to set the local position of the button to the up position. So the way that these two functions are going to work together is each individual button is going to keep track of how many objects come in to collide with it, and it's going to keep track of when they leave, so that only when there is no more objects colliding with it will the button return to its normal position where it's not being pressed anymore. And lastly, I'm going to add a little note in here for later, telling me where I need to add the individual key functions when I get to that part. Now that I'm done with the script, I'm going to add that to each of the buttons and go ahead and set the button pressed offset to 0.006, which is the distance that the button is going to drop down whenever it's being pressed and how far it's going to come back up. I'm not going to set the cursor public variable for now, because we haven't made the cursor. Once I've made that, I'll come back and set that part up. So for the mouse, I already have a PC mouse 3D object in my scene. I'm going to give it two parent objects. The first one is going to be called mouse, and then a parent object to mouse is going to be mouse center. The way I'm treating this, the PC mouse 3D object is just going to kind of go along for the ride underneath the mouse. But mouse center is going to determine where the center of like the mouse pad area is that I'm going to allow the mouse to move around. So there's going to be an offset that tells it how far the mouse can move to the left, right, up, or down. And it's all going to be based off of where the mouse center game object is. So on my mouse parent object, I'm going to add a trigger box collider that roughly matches the dimensions of the mouse. So that is the area that when my hand is colliding with that space, the mouse is going to follow my hand around. Now I'm going to create the mouse controller script and open it up. Again, getting rid of the first two lines. I'm going to use three public variables. The first one is going to be the transform of the mouse center, so I know exactly where it is. And then I'm going to have two public floats that determine the max distance the mouse can go on the Z axis as well as the X axis. I'm adding an onTriggerStay method, and in here I'm going to compare the tag of whatever has collided with that trigger and making sure that it is a hand. If it is, then I'm going to make a new variable called new position, and that is going to grab the X and the Z value for the hand's position, but it's going to maintain the Y position of the mouse just because we're not going to be lifting the mouse up off the desk at all. Once I have that new position, then we're going to clamp the position to the boundaries. So I'm going to check the X and the Z values for this new position and make sure that they are within that max distance. And if they're not, then they're going to clamp them to that max distance so that it can't move outside of that range. And then now that our new position is set up the way we want it, we can now set the current position of the mouse to this new position. And so with this running every single frame, as long as a hand is colliding with the mouse is going to follow that hand around. So I'll add the script to the mouse game object, and then I'm going to set the mouse center public variable. And then I also had a weird scaling issue where the mouse was set to one scale, but the mouse center was set to a scale of 25. So I'm just going to reverse those so that it works the way I need it to. And then real quick, I'm going to open up the player prefab that came with the Steam VR plugin. I added a collider to the left and the right hands. This collider is basically positioned right in the palm of the hand, and I've added a sphere collider that's a trigger, as well as a rigid body. The rigid body, I turned off gravity and turned on the is kinematic. The only reason I added the rigid body is for a trigger method to work. At least one of the two things that's colliding needs to have a rigid body attached to it, so it made more sense for me to add that to the hands instead of adding it to every single object in my scene. I also gave these the hand tag so that when one of your hands is colliding with the mouse, this is the tag that's going to be seen by the mouse and allow it to move around because it knows that is a hand that is moving the mouse around. Now that the movement portions of our mouse and keyboard are finished, here's a quick demo. I can put my hand on the mouse and move it around and it will follow my hand around. And then also I can put my hand on the buttons on the keyboard and you can see them press down. So now getting to the fun part of actually building the user interface on the computer. First thing I'm going to do is go to my monitor and add a canvas. I'm going to change the render mode to world space so that I can set the canvas to only be in a certain spot in my scene. I'm going to reference my notes and set the position, width, height, and the rotation. And then I'm going to add a mask 2D component to it. What this will do is prevent any of my user interface pieces from going off the edge of the screen. And then I'm going to right click on the canvas and add a UI image. I'm going to call this background and then set the width and height to match my monitor pretty closely. I'm going to drag my wallpaper in as the source image, and then I'm going to change the color to green. Then I'm going to go in and add another image, and this one I'm going to call cursor image. I'm going to do the same thing, drag the cursor image into the source image box and set a certain width and height to it. And then I'm going to create a child object that's just empty, call it cursor, and then I'm actually going to take that and make that the parent of the cursor image object. This way it's in the exact same position as the cursor image. I'm then going to add a small offset to the cursor image so that the top left corner of the cursor is centered on the parent cursor game object. The reason for that is because whenever you go to click something, you are clicking whatever is in the top left corner of your cursor usually, and that is where I'm going to add this box collider that is going to collide with my other UI elements that are buttons, and that's how my computer is going to know what I'm trying to click on. I'm adding a rigid body to the cursor so that the trigger functions will work properly whenever I get to those. And then I'm making my computer controller script, which is going to handle all of my user interface interactions, such as clicking or opening and closing menus, things like that. But for this section of the tutorial, I'm just going to focus on the cursor movement for now, and then we'll come back and add that other stuff in later. So I've got my two public variables, one for the mouse game object and another float for the sensitivity of moving the cursor around. Since the script is attached to the cursor, then I can just set the transform.local position equal to a new vector 3, which is going to use a negative mouse position on the x-axis, and then I'm actually going to use the z-axis of the mouse for the y position of the cursor, and then we're keeping the z position the same. Then I'm going to set my mouse public variable and set my sensitivity equal to 2. Now for the demo, you can see whenever I'm moving my mouse around, it is in turn moving the cursor around on the screen in a way that would be expected. Here I'm going to add another empty object under canvas and call it desktop UI. This is pretty much going to hold every bit of the user interface besides the cursor and the background. Something important to keep in mind when working with a canvas is the order in which you stack things in the hierarchy determines what is going to appear on top of something else. So it's important to have the background at the top of the canvas since I want everything showing in front of the background, and then the cursor needs to stay at the bottom because I always want the cursor in front of everything else. Inside the desktop UI, I'm going to add my first UI button. I'm going to call it Groth icon, size it properly, and center it towards the bottom. And I will add my Groth circle image to the source image. Then I'm adding a trigger box collider to it and sizing it the exact same size as the icon. Then I'm creating another empty object inside of the desktop UI, and this is going to be my Groth menu. Inside there, I'm creating a panel, changing it from stretch to centered, and then referencing my notes, I'm going to size it accordingly. And for my panels, I'm not going to throw any image in there, I'm just going to give them a color. Then I'm going to duplicate that panel and call this border, put the border above the panel in the hierarchy so that it will appear behind the panel. And then I'm going to slightly increase the width and the height so that it will appear around the edges of the panel and it actually looks like a border to that window. I'm adding some menu text and centering it at the top. And then I'm adding a nice X button in the top right to be able to close the menu out. And again, with all the clickable objects that I'm adding to this user interface, I'm adding a trigger box collider and giving it the same size as whatever it is attached to. And then the way I'm going to have these desktop components show up and disappear is using the little checkbox up here. In the script, that's going to be referred to as set active, true, or false. So here I'm adding the UI elements into the computer controller script. I've got my three public variables for the Groth icon, Groth menu, and the X. I made a section just for my desktop UI buttons and the functions that are going to be associated with them. My first function is whenever the Groth icon is clicked, I'm going to set the Groth icon inactive by setting active to false. And then the Groth menu, I'm going to set active equal to true. In my next function, whenever the X button is clicked, this one's going to run, and the Groth icon set active is going to be true, and the Groth menu set active is going to be false. And with those functions created, now I need to go back to each of the buttons and set the respective function to be executed whenever that button is clicked. So for the Groth icon, I add the cursor because that is where the computer controller script is located, and then same thing for the X, add the cursor in there, and go select the X button clicked function to be associated with that one. So with the UI button stuff completed, I need to add some stuff from the Steam VR plugin so that whenever I pull the trigger on my controller, that will be associated with clicking the mouse. And then only if the cursor's box collider is colliding with a button on the screen will me clicking the mouse actually initiate whatever function to run. So I'm going to add the Unity engine.ui and valve.vr to the top. I'm going to create a new section of variables called Steam VR stuff. I'm going to have a public Steam VR input source as well as a private Steam VR action boolean for the trigger action, and then a private boolean for if the trigger is being pulled, and I'm going to go ahead and say that that is set to false. In my start function, I'm going to set the trigger action equal to SteamVR underscore input get action SteamVR action boolean, and then I'm going to reference my default and interact UI. If you don't know, interact UI by default is the trigger pull on your controllers. So I'm basically looking for a boolean on if the trigger is being pulled or not. So a little further down, I'm making an onTriggerStay method. This is going to run when the cursor's box collider is colliding with a button somewhere on the screen. So if my cursor is hovering over the Groth icon and it's staying there, this onTriggerStay method is going to run. So the collider other is referencing the Groth icon button's collider. As long as the cursor is overlapping with something, then I'm going to be checking the trigger action. So I'm going to be seeing if the trigger is being pulled from one of my input sources, which could be one of my controllers. If the trigger is being pulled, I'm going to go to the next part where I'm checking if my trigger pulled variable is still set to false. If so, I'm going to set trigger pulled equal to true, and then I'm going to make sure that that other object does have a button component, and if so, I'm going to do the onClick.invoke, which is going to run whatever function is associated with that button. At the end, I'm going to say, else if the trigger is not being pulled, set the trigger pulled variable equal to false. Now, the reason for having the trigger pulled variable in here at all is because without that, as long as the cursor was over a button and I pulled the trigger, I would be constantly every single frame invoking this command. So here I'm saying if the trigger has been pulled, only run this invoked button command one time instead of running it every single frame. So real quick, going back to my cursor where the computer controller script is located, I'm going to set the Groth icon Groth menu and X variables set to what they should be. And here's a quick demo showing whenever I'm pulling the trigger, you can see that by the index finger pulling back. Whenever I do that over top of the Groth icon, it opens up the Groth menu. And then whenever I do that over the X, it closes it. If I do it anywhere else, nothing is happening. So now that our mouse clicking works, we are ready to add in the functions that are going to be associated with our keyboard buttons. So I'm going to make a new section called keyboard buttons and make a back button pressed for the button that was on the far left. This button I want to basically be treated as a home button, so it's going to make everything go back to the way it was at the beginning. So since we only have the Groth menu and the Groth icon for right now, no matter what state the computer is in, the Groth menu is going to be set active to false and the Groth icon will be set active to true. Just for simplicity, I'm not adding any functionality to the delete button pressed or the enter button pressed, but I am showing you enough so that you know how to make these buttons work. So I'm done with the computer controller script. I'm going to go back over to the button controller that we attached to each of the buttons individually. So since the same script is going to be attached to all three buttons, if the button is pressed, it is going to compare the tag against these three different tags and see which button it is. And if it is the back key, then it is going to invoke the back button pressed function. If it's the delete key, it's going to do the delete button pressed function, and same thing with the enter key. So I'll save the script, and then this time we do have a cursor, so I'm going to add that to the cursor public variable for the button controller script, and I'm going to do that on all three of my buttons. And then now I am completely done working on my keyboard for the rest of this tutorial. Next, I'm going to just go through and add some more components to the user interface of the desktop. So I'm starting out with a toolbar, and it's going to have a clock on it. This clock I'm going to set up so that it's showing the real time that it is on your computer in real life. To do that, I'm going to make this very simple script. I'm going to get a public text mesh pro UGUI variable called clock text, and then I'm going to just set that text equal to my system.datetime.now.toString, and then I'm going to format it this way so that it will appear the way that it usually does for me on my computer. Adding the clock controller script to the clock, and then I'm going to grab the text mesh pro component and drag that into the clock text public variable. I'm going to add a simple Wi-Fi icon at the top, and whenever you click on it, it's going to open up a little Wi-Fi menu and say that it is connected to GrothNet. So I'm going to speed through everything else. All I'm doing is adding more stuff to my user interface, more buttons and more menus and things like that. I'm updating my scripts to add that new functionality when these new buttons are clicked, and then making sure I go back to those buttons and attach the functions to them from the cursor, and then also go to the cursor script to make sure that all of my public variables are updated. So now that I've finished building out my user interface, here's my last demo. You can see up in the top right corner that my clock, that is showing the current time that it is in real life for me whenever I recorded this. I can click on my Wi-Fi or the different menus and have these things pop up and close. And then whenever I have a menu open, I can press the back button on the keyboard and it will set everything back to the home screen. If I take the time and really flesh this out more and add more apps in here, I could add a web browser or more settings to change around. I can have a fully functioning computer in virtual reality
You could even add a simple 2D side scroller game to this computer to play inside of whatever other game that you're making. You could really do almost anything with this computer.
that you can in real life. And that's how to make a working desktop computer for virtual reality. Make sure you subscribe to catch all my latest tutorials and share your designs with me if you do make a VR computer like this. It's really cool to see what y'all come up with. I'm Reedster with Far Gaming, and I'll catch you on the next one.